Hello ladies and gentlemen, my name is Garrett and I'm here with two of my friends Gibson and Syafiq. Today we were going to discuss about second order differential equation. To start off, there will be an equation that is a d squared y over dx squared plus b dy over dx plus cy equals to 0, or a y double prime plus b y prime plus c equals to 0, where a, b, c are always constant value. If b squared minus 4ac is more than 0 and there is two roots, the equation will be under case 1, where it will be y equals c1e to the power m1x plus c2e to the power m2x. To solve for m1 and m2, use this method shown here. Stop.
As for case 2, if you obtain only one root from the equation b squared minus 4ac equals to 0, then the general solution will be the one given in case 2, which is y equals to c1e to the power of mx plus c2x e to the power of mx.
Last but not least, for case 3, it only occurs when there are real roots, but b squared minus 4ac must be less than 0, and also m1 and m2 must be alpha plus beta j or minus beta j, where beta must be more than 0, giving a positive number. Finally, we can derive the general equation for the third case, which is y equals to e to the power of alpha x times c1 cosine beta x plus c2 sine beta x.
For example 1, there will be an equation shown here. So how to solve this equation? Firstly, let a equals to 1, b equals to 4, and c equals to 3. Then we will use this equation shown here, they are shown earlier, by subbing in a equals to 1, b equals to 4, c equals to 3 respectively. After that, solve it to make sure that there is two root in the end, where m1 equals to minus 1 and m2 equals to minus 3. Since b squared minus 4ac is more than 0 and there is two roots, it will be under case 1. Next, sub m1 equals to minus 1 and m2 equals to minus 3 into the case 1 equation, and therefore it should get y equals c1e to the power of minus x plus c2e to the power of minus 3x.
On case 2, solve d2y over dx squared plus 6 dy over dx plus 9y equals to 0. Step 1. State the values of the constant coefficients. A equals to 1, b equals to 6, and c equals to 9. Step 2. Form the auxiliary equation and solve the equation by using the formula minus b plus minus square root of b squared minus 4ac over 2a. Sub the respective value into the formula. Solve it until there's only one root, which is minus 3, and therefore the root is minus 3. And lastly, step 3. Depending on the nature of the roots, formulate the general solution, which is y equals to c1e to the power of minus 3x plus c2x e to the power of minus 3x.
An example of case 3. Here we go. We are given y double prime plus 2y prime plus 2y equals to 0. Firstly, express this above equation to characteristic equation, which is m squared plus 2m plus 2 equals to 0. Then solve using the quadratic equation, which is this. Sub in the respective a, b and c value, you will yield a solution m1 and m2 equals to negative 1 plus j or negative 1 negative j. After solving this using the quadratic equation, you will go to the third step, which is, and think of the general equation y e to the power of alpha x c1 cosine beta x plus c2 sine beta x, where m is equals to alpha plus or minus beta j. Since m is equals to negative 1 plus or minus j, we already can know that alpha is equals to negative 1, beta is equals to 1. Sub in alpha and beta into the general equation. You will get y equals to e to the power of negative x times c1 cosine x plus c2 sine x. And after solving this, we have finally got the solution. Yeah!